Hi viewers of Electronics Class Tanzania, welcome again to Electronics Class Tanzania Lesson 8. Today we are going to learn about voltage divider bias or self-bias circuits. In Lesson 7 we learned about stability of a transistor by using emitter resistor, and we analyzed and see how an emitter resistor can stabilize a transistor. We are aware that transistors should operate in an active mode, and the emitter resistor also play a great role in making sure that a transistor is in active mode. Also today, we will also continue with our transistors. Transistor is very wide, but we'll go stage by stage, and eventually we'll be doing practical, because electronics is all about practicals, because at the end you have to build your own circuit, you have to build your own equipment in whatever you want electrons to do, we'll do it for you. Today we are going to learn about voltage divider bias or self-bias. We'll see a circuit of a voltage divider. Also we'll see a circuit of a Thevenin's equivalent. Let's start with the circuit of a voltage divider, and you'll see how it is. This is a circuit of a voltage divider. We have VCC here, and we have our RC here, and also this is NPN. The arrow is going out. This is NPN transistor. So we have our RE emitter. We have said this is a voltage divider, so the voltage is being divided here. So we have our first resistor is, let's call RB1, and we have another resistor here. Let's put RB2. Then we ground our circuit here. Our circuit is grounded there. So this is a voltage divider circuit. RB1 and RB2 are in parallel. RB1 are parallel with RB2. This is a parallel. This is a silicon transistor. So the silicon transistor, VBE, this one, for silicon transistor is 0.7 volts. So our beta will be 150 for these transistors. Let's put the values in this voltage divider a circuit. Let's put here 36 kilo ohms. Here put 4 kilo ohms. Let's put here 1.5 kilo ohms, and here 10 kilo ohms, and this is 20 volts. So let's see the Thevenin equivalent of this circuit. I'll put here the Thevenin equivalent of circuit. Let's have the source, the voltage, then we have the Thevenin equivalent resistor, then we have our transistor here, NPN transistor. This is our RE, grounded. This is our RE. This is the VCC. This is a voltage, and this is RBB, our Thevenin equivalent resistor. So this is our Thevenin equivalent. This is Thevenin equivalent of this circuit. So let's find the values, because at the end we have to find IB, that's base current. We have to find IC, that's collector current. Then we have to find the VCE, that's collector emitter voltage of this circuit by using Thevenin equivalent. This is our collector, this is our emitter, this is our base. So to have Thevenin equivalent resistor is RBB equals to, these resistors are parallel. So RB1 times RB2 over RB1 plus RB2 equals to 36 times 4 over 36 plus 4 equals to, this is simple algebra. We take our calculator and have 36 times 4 divide by 40. We have 3.6 kilo ohms. These are resistors. That's our RBB. 3.6 kilo ohms. Let's find the V, the voltage. The V, the voltage, since this is the voltage divider, we'll take VCC times RB2 over RB1 plus RB2. So this is equal to, VCC is 20 times 20, RB2, or RB2 is 4 over RB1 is 36 plus 4, which is RB2. So we have our voltage here. Here we have 40 over 80. So if you divide, get 2. So we have 2 volts here. So we have 2 volts here. Our Thevenin equivalent voltage is 2 volts. And our RE also here is 1.5 kilo ohms. So we have to find IB, IC, and VC, VCE. Our IB, will get IB through the formula. IB will pass here, IB this way. So our IB is V minus VBE. VBE this one here, or VBE is here, over RBB, which is this one, RBB, plus 1 plus beta RE. Yeah. Since we have already our Thevenin equivalent here, we'll use this one. Then I'll remove this so that I can have a space for having a formula for IB equals to V, which is voltage here, minus VBE over RBB plus 1 plus beta RE. So we put the values. Voltage is, V is 2, minus VB 0.7 over RBB 3.6 kilo ohm, 3.6 K, plus beta is 150 plus 1 is 151, and our RE times RE 1.5 K, that's kilo ohms. Again, on top we have 1.3 over, we'll use calculator for this algebra. 151 times 1.5, 151 times 1.5 plus 3.6, we have 230.1. 230.1, and we divide it, 1.3 divided by 230.1, we have here 0.00565649. These are milliamperes. This is milliamperes. We can put it in micro. 1, 2, 3 is 5.649 microampere. So this is our IB. Then we have to find our IC. This is our IB. Then our IC is equal to beta IB. Beta is 150 times our IB, this one is 0.005649. Then we'll have our IC here in milliampere. I will remove this, so our calculation can be visible, to have a space to do calculation. So it's another algebra here. You can use a calculator also. 150 times 0.005649. We have here 0.847. This is milliampere, our IC. So we need also to find VCE. So VCE is equal to VCC minus IC RC minus IE RE. Get, this is Kirchhoff's voltage law. Then we have the VCE, which is this one, VCE, collector emitter voltage. So by using voltage Kirchhoff's law, we have the collector emitter. So the VCC is 20. We have 20 here, VCC, 20. We minus our IC, the IC, this one, in milliamps, this one is 0.847 times RC, which is 10K. Also, we minus IE, RE. IE is a summation of IB plus IC. We know this formula. And RE is times 1.5. IB, let's have summation of here. We can do summation here. IE is equal to IB plus IC. So we have our IB here. This is our IC, and this is our IB. This one. This is our IC. So our IB is 0.0056647, and our IC this is our IB, and our IC is 0.847. So again we do summation, so we can have our IE here, and we finalize our calculation to have VCE. So again, to have the IE, we can sum up by using the simple algebra. Also you can use calculator. We have 0.005647 plus 0.847. Yeah, we have here our IE is 0.8526, yeah, which we times by 1.5. So we can have the VCE. So we times by 1.5. I have here this 1.278 goes. So VCE equals to 20. We take 20 minus, here's 8.47. 8.47, we minus 1.278. We have here 10.25. This is the volts. 10.25. We can put here 10.25 voltage. So our Thevenin VCE is 10.25 voltage. Our IC is this one, and our IB is this one. So we have seen in today's lesson how we can calculate IC, collector current, which is this one, IC. How we can calculate IB and calculate VCE from voltage divider bias, which we saw in the first when we were introducing, and the equivalent Thevenin circuit, which also assist in getting those values, IC, IB, and the VCE, that means voltage, collector emitter voltage. Hi viewers of Electronics Class Tanzania. In Today's lesson, lesson 8, we have seen how the voltage divider bias and self bias, we have seen how to find collector current, how to find base current, how to find collector emitter voltage by using Thevenin equivalent circuit. We are doing these calculations and decide by using calculations first in order to be conversant before we embark on practicals and making a real circuit, which we'll do later. So don't forget to subscribe, like and comment so many can share and learn electronics class Tanzania. Thank you for watching.